The Arctic, a polar region dominated by cold conditions and the presence of ice and snow. Apart from research bases, this inhospitable wasteland is almost entirely uninhabited. Today, I'm going to talk to you about how recent strides in mechanical engineering technology have further advanced the exploration of this region. I will specifically introduce a recent advance in mechanical engineering, which is responsible for making exploration in the Arctic, in particular the fields of atmospheric and climate research, much safer and more viable than ever before. Arctic robots.
Robots are a rather dated concept, however their use in the Arctic has only begun in recent years. A team of engineers from Dartmouth University, which helped pioneer this innovation, used available robot technologies to create two robots which have already been field tested in both Greenland and the Antarctic.
The first robot, Yeti, weighs in at about 3 pounds. Yeti is a battery-powered tracked vehicle and is fitted with ground-penetrating radar. It remotely operates for hours while trekking through crevassed country. With its light weight, the robot can easily traverse the brittle ice of this Arctic region in order to map its ever-changing landscape. It notes down anomalies along its path and serves as a guide for Arctic convoys. This machine lessens many of the dangers that researchers in the field in such harsh environments would otherwise face by mapping safe routes for them prior to travel. Here's a clip of Yeti in action.
6.5 hours later.
The second robot to be built was aptly named Cool Robot. This robot, unlike its predecessor, was designed to conduct remote sampling as well as atmospheric research. Using this robot allows researchers to eliminate the chance of contamination of samples by contact with humans. Moreover, it mitigates the danger involved for scientists working in those extremely harsh conditions, and the cost of sending a robot is also less than what it would cost for a team to go into the field. Another key difference lies in the vehicle's power supply. Whereas the Yeti is battery powered, Cool Robot is entirely reliant on solar power. Its solar panels are designed so it forms a box around the machine, and as the sunlight reflects off the snow, this allows for it to absorb the same amount of power whether or not it's facing the sun. This is also doubly useful as during the summer, when most scientists go out to conduct their research, there is approximately 24 hours of daylight. The design philosophies behind the two lead robots are fundamentally different. The design for Cool Robot was centered entirely around its solar panels, putting specific emphasis on allowing the device to have to absorb enough energy for each particular mission. On the other hand, Yeti was designed with mobility in mind, as the Arctic region has many large crevasses, all which change sizes nearly seasonally. It is quite difficult to cross over them, and Yeti was designed to overcome this task while at the same time being able to relay topographical information to the researchers.
The use of unmanned robotic vehicles is a vital breakthrough for engineering and, as well, the field of Arctic exploration as a whole. Robots make areas of the Arctic which would otherwise have been inaccessible now open to be properly studied. These vehicles aid polar scientists in these areas by making them much safer to navigate. These devices are able to not only travel in areas outside the reach of man, they are also able to do so without disturbing the region in the process. Through the use of robots such as Cool Robot and Yeti, mechanical engineering is helping to further advance the limits of exploration possible in the Arctic.